Ladies and gentlemen,
our third keynote speaker will present on rainwater photovoltaic application for sustainable society. Our third keynote speaker is none other than Professor Dr. MARWAN DHAMRIN. Graduated from Sana University with a bachelor degree in physics and a master's and doctor degree in engineering from Toyo University of Agriculture and Technology. Professor Dr. MARWAN also involved in Japan Society for the Promotions of Science Fellow and worked at Tokyo University of Agriculture and Technology until 2010. In 2011, he had joined Toyo Aluminium as a manager of solar laboratory director for technologies. He been appointed as professor at Osaka University and becomes senior specialist executive at Toyo Aluminium. He has been granted 15 patents, 35 applications, and over 150 publications referred in journals and international conferences. I'm handing the mic to Professor Dr. MARWAN.
Thanks a lot for the invitation and for the introduction. I would like to express my deep thanks to His Excellency the Minister of Environment and Water, Mr. Tuan Ibrahim, and to Professor Anwar Ibn Ahmed and Professor Ahmed Dabwan for arranging this wonderful event. And also I would like to thank our, the conference previous speakers, Professor Haj Nasser and Professor Suhinda for a great insight and technology refinement of rainwater. I'm not a specialist in water itself or in water industry and refinement, but I'm a specialist in solar industry. So I will be talking today about how we can utilize photovoltaic for rainwater application and for a sustainable society. So sustainable society means that we have affordable energy, we have affordable water, food, education, extra for a great society. And water and energy are both a very important aspect for a sustainable society, because without that we cannot really have a chain of food, a chain of other applications that can help us have a good life. So I would like here to address the outline of my talk. I would be introducing Toyo Aluminium as a company, and also I would then later introduce solar energy and its cost and economics in the recent years in the world. After that, I would give some flood and drainage projects examples from Hong Kong and Tokyo precisely. And after that, to the main topic is how to utilize solar for rainwater applications before I conclude the topic. So just to take this chance to introduce a little bit about our company. Toyo Aluminium is one of the leading company in terms of production of anything related to aluminum. We do aluminum foils, back sheets, and aluminum food packages that can use aluminum foils, and they're laminated with bed films so that for a good food safety. We have a powder and base division that deals with the automobile industry, and we also have a solar department inside the company that responsible for the solar applications and solar material. We have wide world factories in France, in US, in China, and also in Japan. So to start with solar industry, of course, the solar cell or the solar energy device which transfer the sunlight into electricity was invented back in the 50s in the US. However, the price of electricity that generated from these solar cells were extremely expensive. It was like $100 per watt, which means a small solar cell that can produce 5 watts can be really around $500 per a solar cell. However, because of the technology, of course, advanced in technology and advancement in production, we could reach down to now about 20 cents per watt, which means that a solar cell that was costing us about $500, it is no more than $1 today. So that makes the solar cell or the solar energy one of the cheapest energies in the world. So if you can compare gas and nuclear and coal, which by the way, Malaysia is depending a lot on coal, the kilowatt or the megawatt hour prices is above $65 per megawatt. While with solar and wind and geothermal, we can really go down with solar to 30, half of that. So now it's more economical than ever. And the reason is the big expand in production capacity in China that reach around 150 gigawatt of module production capacity. So to follow up with the prices that being offered in terms of electricity, you could see here that the projects of solar photovoltaics compared to the wind and offshore wind, they are reaching really, let's say a 3.9 cent per kilowatt hour in the vicinity of 2020, with some exceptions in some areas, if I may show here, that it reached around 15.6 dollar per megawatt hour, which means that it is about 1.5 cent per kilowatt hour. I suppose that in Malaysia, the prices of electricity is far higher than this. So the message now is that the solar industry or the solar energy is really one of the competitive energies in the world right now. So what about Malaysia? So Malaysia is slowly moving to solar industry. So in terms of solar installation, Malaysia is still far behind other countries like, let's say, China, Japan, and Europe, Germany, USA, still far from there. And the reason is not clear for me, at least, because Malaysia has geographically a very, very good potential. And I show here a map of Malaysia that I take it from this website that shows there is a massive solar irradiance at the whole Malaysia that can really make the solar energy far, far economical in the region. Some other aspects is that at least 4 of the big solar module manufacturers in the world have their companies and factories in Malaysia. To mention here, Hanwha Kyocell, it's a giant Korean manufacturer. They have their factory, which I visited a lot frequently, to Kuala Lumpur. It is in Cyberjaya. It's a very state-of-the-art factory. Another US company called First Solar, they have also factories in Malaysia. Sunpower, another US company, and Chinese giant Jinko has a big factory in Penang. And there's also small other companies not to mention here. So with this infrastructure that already there as a production, I think Malaysia can be one of the leaders in using or utilizing solar energy. So you could see here, this is a very big giant solar power plant in Malaysia. So tell her this is about solar. So how can we use also solar to harvest water? So if you could see this teeny place, it will look like this photo. So I will make it here bigger. So solar, by its way, it's a very good harvesting system. The solar module itself is made of glass in the front. So the raindrops can drop into this really beautiful surface of glass, and then you could really collect the water here and use it. So solar by itself, it can generate electricity, and when it's rain, it will have a very good surface for collecting water. So to mention, for example, Japan can make install about 8 giga to 10 gigawatt of solar modules yearly. Each gigawatt consists of at least 4 million panels of this, which has, each panel has like around 1.5 to 2 meter square in area, which means you can install solar in big farms with millions of square meters, and at the same time you can use that surfaces to harvest rainwater easily. And this is one of the ideas that I'm thinking about. So back to the main topic, which is the rain and clouds in examples. I will show here, an example. This is a Hong Kong West Drain Tunnel because of the rain that accumulates and then goes and flood in the city. So they made a tunnel, a big tunnel that can drain and then discharge. So you can see here that this flooding was like a big problem in Hong Kong, and they solved it with this kind of tunnel that they could collect the water in a reservoir and then bomb it later on the sea. So bombing later in the sea, that means like a little bit of waste. We could have used that water for other purposes, as my previous speakers already shown. Another example, which is called the JCANS project in Tokyo, or the temple, it consists of 5 big shafts. You can see, imagine this shaft here, you can make a huge space rocket inside this shaft. It's really giant, 65 to 70 meters with a 30 meters in diameter. So these shafts can collect the water inside and then assemble it to what they call it the temple. And the temple is really huge, and this is one of the photos that shows inside. And if I may ask Engineer Mohammed Sarah to show this video from his side. Could you share the video, please?
Japan is located in the eastern end of the monsoon Asia. Tokyo has an annual average rainfall amount of 1,700 millimeters, which is equivalent to about twice the global average. Rainfall amounts in Tokyo have concentrated in the rainy season and typhoon season from June to September. In the past, riverbanks and sewers in Tokyo would often overflow during typhoons or rainstorms during this season, causing flooding to affect roads and homes. As the urbanization in Tokyo has progressed dramatically, Tokyo metropolitan government put efforts to develop advanced disaster prevention. One of the principal projects were the development of underground regulating reservoirs and diversion channels to help prevent this flooding. This is the Konda River Underground Regulating Reservoir. It is actually one huge tunnel built under the major road. The construction was complete in 2007. The diversion tunnel temporarily stores excess water from the river channel, which has been a big problem causing floods to thousands of homes during powerful rainfalls.
喫水する前にですね、ゲートを開けまして、この調節池の水をためます。水はドロップシャフトという立て子を通りまして、連絡管を通じて環7の下にある調節池の方にたまるという仕組みです。全部でたまる量はですね、54万立方メートルということでございます。この周りですね、非常に静かな住宅街ということがございますので、ここでドロップシャフトという仕組みを使って、水を取り込むときに音だとか振動を少なくするということを行っております。これがドロップシャフトです。水を取り入れるとここからですね、落ちてくるという状況です。いわゆる渦状になって降りてきます。この連絡管を通じて本管の方に行きます。約40メーター上にですね、環状7号線が通っております。内径 12.5 メートルですね、また JICA の方々、研修で勉強される方も含めてですね、この施設をご覧になって、お国の方に戻って、参考にしていただくということをしております。
Thanks a lot for sharing. I would move to the next thing now, is how we can utilize solar and other applications. I'm still there. Can you hear me?
Yes, doctor. Yes, doctor.
Loud and clear.
Sorry, can you hear me?
Yes, we can, doctor.
Okay, so I'll continue. So the biggest question is how we can use or utilize solar for rainwater applications. I will just give you an example here. It's a project in Gordon Butte in the USA, and they use a bomb hydro of 400 megawatts. What they are actually doing is a kind of artificial dam, or you can say instead of a dam, it's a big tanks. So they make in the height a big reservoir of water tank that they could bomb water from down up using low-cost electricity, for example, a solar in the daytime, and then when the reservoir filled, they can use this water as a battery. So when it drops down to the down tank, it can generate electricity. So we can use water actually as a very good battery if we could have a geographical thing that can help us, and also a low-cost electricity like solar to pump the water up during the day and then use it as a battery in another time or when needed. It's one option that's in the momentum right now, because with solar it can be really cheaper to pump during the daytime the water up, and during the night we can use it, because we cannot solar energy at night because there is no sun actually. So this is one example. The other example is, of course, Professor Suhinda mentioned a similar way like this with very great ingredients that is in the nature, that the simple villages can use that with a simple material that they can filter the water and use it as an underground tank and then discharge it for the wells or bomb it a little bit for irrigation. Here I use the similar idea but with a little bit of modification of cheaper energy that comes from solar energy. So we can use solar energy to first help with filtering and UV the water before it goes to this underground tank, and also use a solar pump or solar operated pump to take the water up to the water tanks. And also we can use a UV LED, which is nowadays, it's a very affordable, because we can use aluminum nitride wide band gap to generate multiple UV frequencies that we could use to sterilize water and make it even used for with a proper filtration that can be used for also not only irrigation but also for drinking. So once we have this water tank, I would like to introduce you to another system which we are in Toyo Aluminium are now developing. So we are developing a kit tool that is really measuring the moisture. So it's a moisture sensor, and with a very good and a great reliability, and also predict quality is really high detection quality. So with these sensors, we could really monitor the moisture in the ground or in the soil. So how can we use that system in a smart irrigation system? So we can use small solar panels, not necessarily big, it's just enough to operate these sensors. We can then the system will contain a sensor, it contains a control unit and a small battery discharge, so this can work at 24 hours, a connected Wi-Fi or wireless communication, even 4G, 5G, Bluetooth, whatever that you can need as a communication inside the device, and it's cheap electronic nowadays. So the process will go as follows. The sensor can detect a moisture in the soil, report to the control unit. So if this goes below, for example, 20, then automatically electrical valve will open and then the water can go out. And when moisture is enough, for example, let's say 80% in the soil, then we just close it off. So small kits like this can really make use of water, so that you can use it as an irrigation system, and you can make it in very separate locations across your field, and use that to smartly use the water without any, what can I say, any loss or like waste. So why we use these systems? We can use automatic, of course, like with time, like a 5 o'clock open, 8 o'clock close or something like that. Yes, we can use that. But of course, there is some days that there is a lot of rains. So why we are wasting that, like that water? So with this system, it measures and tell us when we need, and it is connected so that in a headquarter, you can know that all your field or all your area, when they need water, and you can control the amount of water that goes to the ground. So with that, I would like to conclude that photovoltaic energy is becoming, like solar energy, is becoming really affordable and very low cost. And we can use it for also helping harvesting water, and also to make a smart technology to make the best use of our water. Looking forward for any people who would like to collaborate in such projects in the future, and you can visit us at toyal.co.jb for more information about these devices. Thanks a lot.
Thank you, Professor Dr. Marwan, for elaborations on the rainwater photovoltaic applications. We are all very honored to have you here to share all the knowledge and all the what we call it high-tech technology that you have created.